Okay, let's say I want you to find the missing pieces of information for a triangle with these measures. Okay, see if you can apply. I'll call this ABC. You want to find angle B, angle C, and side A. Okay, and then again, the form that I will give you on any quiz or test for the law of cosines will be this form. So even if you're not solving for C, the relationship should still be apparent. The nice thing with this pattern is you can always just type it into your calculator, use the solve key, and it'll give you your missing value. Okay. So the piece that you're finding first is going to be what? A. So let's start with, here's what we start with. So the outer parts are going to be this pair of information. So 30 goes on the far right, A goes on the far left. And so you'll hear me describe the equation as I write it down is A squared is equal to the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle opposite A, which is 30. Again, the nice thing with this is it fits right into our calculator. Solve for A.
So if you get a plus or minus.
Right, so it's going to give you a positive and negative root. Do we even need to consider the negative roots for distance? No. So we can enter this in, solve, and I'm just going to use an x instead of the a just for the sake ease of writing it. But x squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 30. I'm going to put a decimal in there. I want to solve for x and hit enter. I get my answer, and again the numbers are going to be plus and minus the same thing, but you get 4.44 approximately. So there is my side length. All right, what I want you to do is see if you can find what angle C would be. Because in this calculation, I'm going to use this 4.44 a couple different times. What I'm going to do to make it easier is I'm going to highlight this answer, hit enter. I'm then going to delete everything other than the solution itself. So I'm going to delete all the x equals stuff. And then I'm going to hit enter again. The whole reason I do that is now this exact answer has a line of its own, so I can highlight it anytime I want and copy it into the bottom of the screen. And so that's the only reason I put that there. And now I can solve this equation. And so I can take 8 squared minus 5 squared minus this quantity squared. Hit enter. Now I'm going to divide that by the entire quantity, negative 2 times 5 times, and again, this exact value. Close it off. Hit enter. So here is my cosine ratio. Negative 0.434 approximately is the cosine ratio for angle C. So to solve for C, I'm going to take the inverse cosine of this value. And when I do that, I can just highlight it. I get my angle to be 115.7.
Take the 2 minus 180 and see the...
Okay. So now, as we go through this, we can take the sum of these, 180 minus 30 minus 115.7 is equal to, and then we get our answer of 34.3 approximately. And so we now have all the pieces of information. Okay, now, is this consistent with what you would expect?
Yes.
Is the largest angle opposite the longest side?
Oh, yeah. Yeah.
Smallest angle opposite the smallest side. These two angles are relatively close, so the sides opposite them are relatively close. Did anybody use a different method to solve for C? Anybody use the law of sines?
I did, but I think I messed it up.
No, you didn't mess it up. Did you get like a 64.3? Okay. So let's talk about what happens in that case. Okay? All right, so let's say instead of using the law of cosines to find angle C, since law of sines is now available, we have SSA, we could use law of sines, and often it's a simpler calculation or a real easy setup. Okay, so here's the calculation if you're using law of sines for this. I'll try to keep it all here on the same sheet. Okay, so C is our unknown. So I'm going to say the sine of C over the side opposite it has to have the same ratio as our known pair. And so either of these pairs would work. It doesn't matter. Or actually, we don't have this angle yet. So we have to use this set. So we get the sine of 30 over our exact answer, but the 4.44. Okay, so to solve for the sine of C, we'd multiply both sides by 8. And we can find what our sine ratio is. And so if we calculated that, we would get the sine of 30 times 8 divided by, and I'll go up and use that exact answer right here. Okay, so here's my sine ratio, 0.901 approximately.
Take the inverse.
Take the inverse sine of that. Okay, and if you do this process, you're going to come up with your 64.3. And now, if you looked at this problem here, 64.3, which means what's angle B going to equal?
A way bigger number.
So if we take 180 minus 30 minus
100 times.
this, we get 85.7 approximately. Now, is this consistent with our picture?
No.
B would, in this case, B is the largest angle. Is the side opposite that the longest side? No. Hey, when you guys get into trig stuff and you talk about the unit circle, what you're going to find is sines, like the sine of an angle, corresponds to two different angles, one in quadrant 1, one in quadrant 2. What that means is for every sine ratio, there's one angle from 0 to 90 degrees that has that sign, and one angle from 90 to 100 degrees that has the same sign. So when you use your calculator to take the inverse sine, it's just telling you the angle in quadrant 1. And there happens to be another angle from 90 degrees to 180 degrees that has the same sine ratio. And the way that you find that is it's the supplement of it. So that's how I was able to tell you right from looking at this problem. When we got the answer of 115.7, the answer that you'd get using law of sines is going to be its supplement, 64.3. So if you do it this way, there's a couple things to keep in mind. If you're going to use the law of sines, find the smaller of the remaining angles. Okay, so if I told you find side A, angle B, and angle C, which angle is going to be smaller, B or C? You know B is smaller, right? Because it's opposite a smaller length side. So if you're going to do this, find B first. Because that means your smaller angle is guaranteed to be acute, right? Because you can't have two obtuse angles. So if you find the smaller of the remaining angles, then you don't even have to worry about the fact that the inverse sine might give you the wrong angle. Okay, so you can still use law of sines, but if you use law of sines, you have to find the smaller of the remaining angles first. Okay, does that kind of make sense? Or?
If we were to do it that way, could we find the supplement and then just plug it back in?
Or if you find this and it's inconsistent, just take its supplement and then you have all the other measures too. Yeah. Okay. All right. Probably more subtleties in this section than anything that we've done so far, right? Like kind of like SSA can be two triangles as long as you know why. The law of sines may not work as long as you know why. So again, there's some set rules that you can follow to alleviate that. The first one is if you just use law of cosines, it's guaranteed. Because again, between angles from 0 to 180 degrees, none of those angles have the same cosine value. So like using law of cosines will guarantee you'll get the right answer, which is why that's what I chose. But if you do the law of sines, just make sure you do the smaller angle first. All right.